Are you struggling with algebra? Well, let's fix that right now. Today, we are going to master pair of linear equations in two variables. Look, this chapter isn't just crucial. It's actually a pretty easy way to score some big marks on your exams. Seriously, this is where your whole algebra foundation gets built.
Okay, let's make this real for a second. Imagine you and a friend go to a shop. You buy a few notebooks and pens. Your friend buys a different amount. You both know how much you spent in total, but you have no idea what one single notebook or one single pen costs. So how would you figure that out? Well, that exact puzzle is what linear equations are built to solve. So here's our game plan for the next few minutes. We'll kick things off with the problem itself, then look at solving it with pictures, and then with algebra. I've also got a really cool 3-solution secret for you, and we'll wrap it all up with a summary and revision. Ready? Let's jump in.
All right, first things first. What's the problem? Let's really understand the basics here and break down what a linear equation in two variables actually is. Okay, so when you see an equation that looks like this, ax plus by plus c equals 0, don't let all those letters intimidate you. It's actually super simple. All that equation means is a perfectly straight line on a graph. That's it. Every single time. That's the one key visual you've got to lock in your brain. Okay, next up, let's talk about solving with pictures, the graphical method. This is all about getting a feel for what the solution actually looks like.
Just think about it for a second. If you take a piece of paper and draw any 2 straight lines, what can happen? Really only 3 things. 1, they can cross each other at just one single point. 2, they can be parallel, kind of like train tracks, right? They'll run alongside each other forever but never ever touch. Or 3, they can be the exact same line, just one drawn right on top of the other. That's it. Those are your only options.
And right there, in that simple idea, is the secret to what a solution actually is. It's just the point where the lines meet. So if they intersect, boom, you've got one unique answer. If they're parallel, well, they never meet, so there's no solution. And if they're the same line, they're basically meeting everywhere, which means you have infinite solutions. See how simple that is? Okay, but let's be real. Drawing graphs isn't always the most practical thing to do, right? Especially when you're in an exam and the clock is ticking. You need speed, you need precision. So let's move on to the algebraic methods that will give us the exact answer every single time. The elimination method. Now this is a fantastic tool, mainly because it's so systematic. The name says it all, right? Your goal is to get rid of or eliminate one of the variables, either x or y. And how do you do that? You just tweak the equations to make the coefficients, the numbers in front of the variable, the same. Then you either add or subtract the equations and poof, that variable just vanishes. You're left with a super simple equation that's a piece of cake to solve. Let's actually see this thing in action. So we've got these two equations. Say we want to eliminate y. All we do is adjust both equations so the y terms become identical. In this case, they both become 6y. Now for the magic part. We subtract one equation from the other. The y term completely cancels out, leaving us with something really simple, 5x equals 25. And from there, it's easy, right? X must be 5. Then you just plug that 5 back into either one of the original equations, and you find that y is -2. See, it's a really clean, precise method. Okay, now you're going to want to pay really close attention, because what I'm about to show you is the ultimate exam trick. What if you could know the type of solution, whether it's 1, none, or infinite, without drawing a single line and without solving a single equation? Well, you can, and this is the secret. The secret? It's hidden in plain sight, right there inside the equations themselves. We don't have to solve for anything. All we need to do is compare the ratios of the coefficients. That's just the numbers in front of x, the numbers in front of y, and the constants at the end. Okay, this table right here, this is pure gold for your exams. I'm serious. You absolutely have to memorize this. Look how simple it is. If the ratio of the x's isn't equal to the ratio of the y's, bam, one solution, intersecting lines. If the first 2 ratios are equal, but they're not equal to the third one, that's parallel lines, no solution. And if all 3 ratios are exactly the same, it's the same line, with infinitely many solutions. This trick will save you so much time. And hey, here's a super simple memory trick, just to lock in that first, most common case. Just tell yourself this: not equal at the start, they have to cross once. That's it. If that very first ratio, the A's, isn't equal to the second ratio, the B's, you can stop right there. You know for a fact that there is exactly one unique solution. Game over. All right, let's put this all together now.
we're going to tackle a classic exam-style problem. This is where we get to test everything we've just learned. And after that, we'll wrap things up with a final summary. Okay, this is a total classic. You see problems like this on board exams all the time. Now, with any word problem, what's the first step? It's always the same: define your unknowns. So let's do that. We'll let the fixed charge be x, and we'll let the charge per kilometer be y. Once we have our variables, building the equations is actually pretty straightforward. For the first trip, it's x plus 10y equals 166. For the second, it's x plus 15y equals 256. Now look at that. The x's are the same in both, which makes this perfect for elimination. We just subtract the first equation from the second. The x's cancel out, and we're left with 5y equals 90. A quick division tells us y is 18, so the charge per kilometer is 18 rupees. Now we just substitute that back into one of the original equations, and we find that the fixed charge x is minus 14. Yeah, I know it's a weird number for a taxi fare, but mathematically, that is the correct answer based on the numbers in the problem. So let's recap the whole chapter. What are the big takeaways? Number 1, linear equations are just straight lines. That's all they are. Number 2, a pair of these lines can have 1, 0, or infinite solutions. 3, you can solve them with pictures using the graphical method or get exact answers with algebraic methods. And finally, number 5, your secret weapon, your ultimate exam trick, is using those coefficient ratios to find the number of solutions in seconds. Okay, now it is over to you. For real, the absolute best way to learn math is by actually doing it. So I want you to pause this explainer right here and really give these 10 revision questions a try. This is the part where all these concepts go from your screen into your brain for good. All right, here are the first 5. And you'll see we've got a mix of everything here, from simple cost problems to a bit of geometry. Go ahead and pause right now. Just focus on setting up the equations for each one. Honestly, that's always the hardest part. Once you've got the equations, you're halfway there. And here are the next 5, designed to really test your skills. Quick tip, pay close attention to number 7. That's a perfect place to use our little exam trick. And just so you know, problems like the boat one and the 2-digit number one, those are absolute favorites on exams. So pause here, give them your best shot. Good luck. And that brings us to a final, kind of bigger thought. Look, being able to solve for 2 unknowns is powerful, for sure, but it's really just the beginning. It leaves us with a huge question. What happens when you have 3 variables, or 4, or thousands? Think about what it takes to model a country's economy, or to predict the weather, or to program an artificial intelligence. It takes solving systems with tons of variables. And the amazing thing is, the very same principles you learned right here today are the foundation for solving all of those incredibly complex systems. What you've mastered here isn't just a chapter in a textbook, it's the first step into a much, much larger world.